Hello good people, I'm going to demonstrate how to calculate the point of intersection. Here is our problem. What is the point of intersection for straight lines with equations y equals 2x plus 30 and y equals 4x plus 20? While I know that you are all eager to see the algebraic solution, let me solve this problem graphically first. Since we have equations for two straight lines, I'm going to plot them. To that end, I need some axes. What should be the intervals on my axes? The equations can help me make a decision. If I look at the y-intercept for both of these equations, 30 for blue and 20 for orange, both of them are in their tens. And because my y-intercepts are in their tens, those are going to be my intervals on the y-axis. So here they are, 10, 20, 30, and so on. What about the intervals on the x-axis? There, the values of the gradients are going to help me. The gradient for the blue line is 2, whereas the gradient for the orange line is 4. These values are in their ones, or units. And so the intervals on my x-axis will be in their ones as well. And here they are, 1, 2, 3, 4, and so on. To plot any straight line, I need at least 2 points. Let me deal with the blue line first. Based on the equation alone, I know that the y-intercept for the blue line is at 30, so I can already plot that point. Now I need a second point. In other words, I need to pick a random x value and calculate the corresponding y value using the blue equation. What x value should I pick? It does not really matter. But once again, I'm going to use the values for the y-intercept to guide my decision. The y-intercepts are in their tens, 30 and 20 respectively. So the x value I'm going to pick is going to be a 10. For the blue line, that would mean that y equals 2 times 10, which is 20, plus 30, which is 50. So I can say that when x is 10, y should be 50. And that is the point that I'm going to plot on my graph. Now that I have my 2 points, I can connect them with a straight line. And now we have the line for the blue equation. Let's do the same thing for the orange equation. Once more, I need 2 points. The first point is the y-intercept. It is at 20. The second point I'm going to calculate the same way I've calculated the second point for the blue line. I'm going to say let x equal 10 and see what happens. So for the orange equation, we would have y equals 4 multiplied by 10, which is 40, plus 20, which is 60. Therefore, my second point is at 10, 60. I have 2 points, I can connect them with a straight line. And here we have the line for the orange equation. The point of intersection happens to be here, at 5, 40. Recall that the point of intersection is where the line equations are equal. And now we get to the algebraic solution. If the line equations are equal, I can make the following statement. Blue y equals orange y. How does that help me? Blue y also happens to equal 2x plus 30, so that is what I'm going to write. Orange y equals 4x plus 20, so I'm going to write that as well. And now it is a matter of transposing to solve for x. I'm going to subtract 2x from both sides, and that will give me 30 equals 2x plus 20, and then I'm going to subtract 20 from both sides. That will give me 10 equals 2x. The final step is to transpose the 2 by division, which will give me 5 equals x. This is telling me that at the point of intersection, the x-coordinate is a 5. What about the y-coordinate? To calculate the y-coordinate, I need to substitute this 5 into either of my equations. I'm going to do it for both. If I have done everything correctly, I should end up with the same result. Let me firstly deal with the blue equation. So I'm going to say let x equal 5 and see what happens. Y equals 2 multiplied by 5 plus 30. 2 multiplied by 5 is 10, plus 30 will give me 40. Let me do the same with the orange equation. Once again, I'm going to say let x equal 5, and then see what happens to y. Y equals 4 multiplied by 5 plus 20. 4 multiplied by 5 is 20. 20 plus 20 is 40. Great. Both of my equations are giving me the same solution for y when x equals 5. And what is even better, my algebraic solution matches my graphical solution. The algebraic solution is telling me that the point of intersection is when x is 5 and y is 40, which is exactly what I read from my graph earlier. Now, you might be wondering, why solve this algebraically when we can solve it graphically? Two main reasons. One, the algebraic method, regardless of whether you believe me or not, is the faster way to do it. And secondly, graphs are not always accurate. If I had picked different intervals, or if my equations were a little bit more unkind, it would be difficult to accurately read the point of intersection. In summary, when calculating the point of intersection, the first step is to make the two equations equal. Once we have done that, we solve for x. Once we have x, we substitute it into one of the two equations. For safety, you can substitute it into both. Provided that we have done everything correctly, we should end up with the same result. That is all for now, and I will see you on the flip side.